All right, ladies and gentlemen, welcome back to part two of calling out a younger creationist. This is part two of this particular video here. And I wanted to address something. I realized that I had said something wrong in the beginning of part one. I had said that all the rocks in the Grand Canyon represent marine rocks, and that's not necessarily true. We do have a number of amount of terrestrial rocks that have been found within the Grand Canyon. One of which being the most obvious one, the Coconino Sandstone, which is lower Permian in age, which is a windblown sandstone in an aeolian deposit that has reptile tracks. And I do actually have a sample of that, not from the canyon itself, but outside of the canyon. It is a quartz windblown sandstone or quartz arenite that has reptile tracks on it. So that is a terrestrial unit. We also have parts of the Supai group, which is Pennsylvanian in age. And the Supai group represents, of course, marine transgression and regression. So we see a level of sea level rise. And in that sea level rise, we do see marine fossils like crinoids and horn corals. But in that sea level fall, we do see amount of sediment that gets deposited in a terrestrial unit. So we see terrestrial mudstones and things of that nature that contains plant fossils. So there are terrestrial units within the Grand Canyon. And I knew that before, I just didn't address it. So I just wanted to talk about that for a little bit. I made a small mistake or a small error within that earlier in the presentation talking about the Grand Canyon. But we are back to talking about or picking up where we left off on the fossils from the Mammoth Cave system. And where we left off, he was talking about the fish or the sharks rather that were found in the cave system within Mammoth Cave in Kentucky. And we were talking about the differences between modern sharks and the fossil sharks that are found within the Kentucky Cave or the Mammoth Cave area. And these are all elasmobranchs, and elasmobranchs consist of modern sharks. They're cartilaginous fish, and cartilaginous fish. Not all cartilaginous fish are sharks, but they do represent sharks. Elasmobranchs are a group of cartilaginous fish that do contain sharks. But these particular sharks that are found within the Mammoth Cave are not modern sharks. These are a variety of different extinct groups of elasmobranchs, like the tenacanthiforms and the pelodontiforms. So these aren't modern sharks. Shark is a loose term that is typically used within this context, but I wanted to make a clear distinction between sharks living today and then the extinct elasmobranchs that we find in the Carboniferous rocks in the Mammoth Cave system. And I want to also mention a little bit of plug-in, but that's also part of my academic research, are on these particular sharks or these ancient Carboniferous elasmobranchs. So I kind of wanted to mention that. So without further ado, let's finish off this video.
I mean, we're talking hundreds of feet under the ground inside the Mammoth Cave system in Kentucky, in the middle of the United States. A bunch of schools of sharks are buried there, just stuck in the rocks. How did they get stuck in the rocks there? Obviously, they were swallowed by a bunch of sedimentary materials from a water catastrophe.
No, not at all. This was an ancient ocean some 340 million years ago, where you have the deposition of carbonate rock like limestone and shales that are being deposited in this ancient shallow sea. So the sharks or the cartilaginous fish that were living in that ancient sea died and got preserved as fossils. In fact, within the ceiling, within the Mammoth Cave region, we do actually find like shark teeth and a different variety of different skeletons of these ancient cartilaginous fish, these elasmobranchs. In fact, a good friend of mine, Dr. John Paul Hodnett, has done a lot of research into describing these fish, these sharks that are found within the Mammoth Cave region. He has collected a lot of the fossils that are from there, and he has studied this. And I also work with John Paul Hodnett as well on describing some of these Paleozoic sharks, not found in the Kentucky Cave region, but I have a published paper with him describing a particular fossil shark or elasmobranch that is found within the Grand that is found within Georgia, which is where I'm from, specifically from the Lavender Shell member of the Fort Payne Formation. So I have done some collaboration with him in the past and will continue to do some collaboration with him because he's one of the top most experts within this particular area. So now these particular fish died in that region and were buried in sediment and got preserved as fossils. And again, cartilaginous fish like sharks, for example, their fossil record is very spotty. The skeletons of these fish are composed of cartilage, and cartilage hardly ever fossilizes within the fossil record. So the only things that we typically see that are represented within the fossil record are hard parts, and that includes their teeth. Teeth are composed of like dentine and fluoroapatite and things of that nature, and so they get preserved very well in the fossil record rather than a skeleton that is composed of cartilage. So we do actually do find cartilage, and we actually do find whole skeletons of these cartilaginous fish. That can happen, but you need really good preservation biases to preserve such material. So I don't exactly know how this would represent a global flood, but again, these are fossils that represents the animal died in that area and got preserved as a fossil. It doesn't really show anything about a global flood or a watery catastrophe. These organisms are lived in an ocean environment or a shallow sea environment.
Is this making sense? I mean, you don't see sharks in Kentucky these days, and much less sharks that are deep under the earth, buried down there. You know, it's interesting. I was out in New Mexico earlier this week, and I was looking at a number of fossils, including shark teeth. I found a bunch of shark teeth in New Mexico, up on a high plateau around 6,500 feet above sea level. In New Mexico, I found a bunch of shark teeth. But here we're looking at Kentucky. I mean, these things, these ocean fossils are just everywhere. You cannot avoid them. We cannot avoid the evidence that is there.
The evidence of what exactly? The evidence that the sea level has changed over hundreds of millions of years? Yeah. Um, New Mexico was under an ocean many different times within the rock record, and we can clearly see that. But this is a large expanse of time we're talking about here. It wasn't just one time that New Mexico or anywhere was covered under an ancient sea. Many times, and we can see that recorded in the rock record. Um, Actually, let's get into the Western Interior Seaway. I definitely wanted to talk about that because this is where this is going to go. He's going to talk about like other marine fossils being found, in the middle of the continent, and I kind of wanted to discuss why the reason why that is. So we already talked about our sharks. Let's talk about the Western Interior Seaway. So the Western Interior Seaway is probably one of the more famous um, continental or epicontinental seas that existed within Earth's history. There have been many that have existed in the past, but the Western Interior Seaway is probably one of the last epicontinental seas that existed within the rock record that we see in Earth's history. And the Western Interior Seaway has a bunch of rock units that are represented. And so one of them is the Niobrara Formation, or the Smoky Hill Chalk member of the Niobrara Formation in Kansas. And it also represents places that are found in Iowa as well. But the Niobrara Chalk is an extremely important rock unit, and it actually shows it's found in the middle of the United States. It shows us that in the middle of the United States. So the Smoky Hill Chalk was deposited in the late Coniacian through the early Santonian, or all the way through the Santonian, and then through the early Campanian parts of the Cretaceous period. So we're talking around 85 to 90 million years ago. And the Western Interior Seaway started to close about the very end of the Cretaceous period, between like 66 to 67 million years ago. And we find an abundance of marine fossils because there was a large seaway that stretched all the way from the Arctic all the way down to the Gulf Coast. And we see a variety of different types of marine fossils that are found there. Things including plesiosaurs, mosasaurs, a wide variety of invertebrates like inoceramic clams and ammonites. And we see a large deposition of chalk and mud being deposited in these ancient seas. The Cretaceous period was also a time where we had high amounts of sea level rise. And it didn't just stay in one area. The Western Interior Seaway rose and fell over the hundreds of millions of years that it existed until the end of the Cretaceous period. So the rocks that we see that represent the Western Interior Seaway have their own different um, uh, fossils that are found in them. So the fossils that we find in the Smoky Hill Chalk are going to be quite different from the fossils that we found in the Pierre Shale or the Bear Paw Formation or the Bear Paw Shale. We still see groups represented that are found within the Cretaceous, like inoceramic clams, plesiosaurs, mosasaurs, ammonites, but they are not the same mosasaurs, ammonites, and inoceramids that are found within the early stages of the Western Interior Seaway when it started to form, when these rocks started to form. And we can find this. I mean, it's literally in the middle of the continent. And again, all of these rocks represent a rise and fall of sea level. And that rise and fall of sea level is what causes the variety of different sedimentary rocks to be deposited. And they're known from different names. So the Niobrara Chalk Formation is only one unit of rock that represents the rise of the Western Interior Seaway or rise of the sea level. And in Eastern North America, it was something completely different. Yes, the Western Interior Seaway did affect Eastern North America or Appalachia, but we also call it the Mississippi Embayment. And that was more of a separate sort of seaway that kind of existed during this time. Still part of the Western Interior Seaway, but it lasted a little bit more when the Western Interior Seaway started to close. And during this time, North America was separated into two parts, Laramidia to the west and Appalachia to the east. And we see two different types of fauna that is represented, terrestrial and marine fauna that is found on Laramidia from the terrestrial and marine fauna that is found in Appalachia or Appalachia. So two completely different fauna groups that are represented because of that isolation and because of that seaway starting to move in the middle of the continent. So how do we know the Western Interior Seaway was here? Well, this map of the United States, there everything highlighted in blue represents fossils that have been found from the Western Interior Seaway. And by collecting fossils and by looking at biostratigraphy, which is the study of fossils within their rock groups, and then when we look at the lithostratigraphy, which is understanding the variety of different rocks in a stratigraphic column, and biostratigraphy, as I said, looking at fossils through a stratigraphic column, we can use those fossils and those rocks to be able to tell exactly where the seaway or how the seaway looked. And by using things like this, we can reconstruct maps like the one on the right here that shows the Western Interior Seaway. And we can reconstruct how this would have looked like during the Cretaceous period. So let's go back and let him finish this off. We're only going to be listening to a little bit because all of the rest of what he does, he doesn't really use any evidence. He just makes claims. But all he does at the end of this video is just post Bible verses and things from scripture. And honestly, guys, I respect religion. I'm not a person that attacks a person based upon their religion. But when I see somebody be completely dishonest like this, it really makes me upset because, again, you're not looking at the evidence. You're making claims and you're pretending like those claims are the evidence that you're trying to show here. But when you actually take a deep dive into the extensive amount of geology and paleontology that is represented through the literature, things don't make sense and things don't point to a global flood scenario. Again, these are all represented within the rock record, and one can look at this information and they can interpret however you want to interpret it. But the actual real interpretation, the evidence-based interpretation, is that sea levels have risen and fallen over millions of years, not because there was just a single flood that caused all of this stuff. Do floods happen? Yes. Do we see localized floods? Yes. Do we see evidence of a global flood? Absolutely not. And the rock record says it does not show that whatsoever. So let's continue this video out. We're not going to watch the entire thing, but we're going to really kind of nitpick about the things that he says here. So let's go back to the YouTube video.
So here's some other fossils from France, from some fossil beds there, 20 different sand dollars buried in France. Obviously, that stuff would come from the ocean, but here it is buried inland. These fossils.
Yeah. Sea urchins do come from the ocean, and $10 do come from the ocean. Yes, and France was covered under an ancient sea over millions of years. I have collected fossil sea urchins in Mississippi. I have found some in the Ripley Formation, and I have found some in the Prairie Bluff Chalk, which represents the last deposition of Cretaceous rock that we see in Alabama and in Mississippi. This represents around like 66 or 67 million years but before the asteroid hit 66 million years ago. So we actually do see that deposition of that chalk, and we can find a whole bunch of marine fossils within it. Okay, yeah, we find marine fossils. That doesn't represent a global flood scenario, especially if you look at the lithology. And mind you, these are all fossils that are from the Cretaceous. We don't see a mixture of Cambrian or Mississippian or Silurian fossils. These are all represented by their geologic environments and by geologic time. We can use chronostratigraphy in order for us to understand where these fossils come from. We use things like index fossils, for example. Ammonites make really good index fossils for the Jurassic and Cretaceous. So a specific ammonite that was found in a particular rock that is only represented within that short period of time, but is found globally, that is widespread, we can then be able to say that this particular ammonite only lives in this particular period because it's restricted to this time period. So we can use things like ammonites and oysters and things of that nature, mostly marine fossils, but also some vertebrates, to be able to tell exactly where we are in geologic time. That is index fossils. So that's what we have. That's what the science of biostratigraphy uses. Now, things like radiometric dating, we have to use radioactive elements in order for us to get an absolute age. But I've had conversations with him in the comment section, and he doesn't even think that radiometric dating even exists or even is a thing, and it's not accurate. So there's really even no point of even talking about radiometric dating to him because he completely disregards radiometric dating as a science. So yeah, that didn't go down the way I was hoping it, because I was hoping he would be a little bit honest here. But honestly, he's not. He's, again, taking small bits of information and he's making it seem to his audience that a global flood scenario is accurate when it's not. Again, taking small bits of information and not really doing any research to the stuff that he's talking about. And again, this presentation that he's doing is just awful. All of its claims, and a lot of the stuff in the presentation was completely wrong anyway. Calling the Green River Formation an ocean deposit, or calling the fish that are found within the Green River Formation an ocean, which is obviously not true. And again, even if it was an ocean, that doesn't represent a global flood. It just represents a sea level rise. This doesn't represent a global flood whatsoever. He doesn't really do any deep diving into what he's trying to push to his audience. He just pushes it because he's a younger creationist and he doesn't know any information about geology or paleontology enough to debunk any of this stuff. So I think we're going to leave it here. He goes on and talks about the Dolomites, but it's the same thing. He says we find marine fossils in the mountains, and then implies that the reason why we find these marine fossils is because of a global flood, when that's not the case. The reason why we find marine fossils in the mountains is because parts of those mountains were not mountains at one point. They were parts of the ocean floor, and they were pushed up due to tectonic activity. And and many younger creationists agree that plate tectonics happens. They completely disregard the timeline. They believe in catastrophic plate tectonics, which is, it has its own problems. But again, a lot of younger creationists accept plate tectonics. This particular individual apparently doesn't accept plate tectonics. And again, we're not going to finish the rest of the video because it's the same stuff. He talks about marine fossils and says it's evidence of a global flood, making claims, and thinks that those claims are evidence. And then he uses Bible verses to back it up as if the Bible verses is evidence of itself. And yeah, it's just really frustrating. And I really just had to, go on and talk about this. But we're going to leave it there. I hope this was an insightful presentation. Again, I don't really do stuff like this, pointing out calling out younger creationists, but guys, I had to really point this out to you because this is just a gross misrepresentation of science. So I'll be back with more videos, more talking about geology and paleontology. But until then, I hope you guys enjoy the rest of your day, and I'll see you later. This is Paleo 101.